Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at solving quadratic equations. On the screen here, you can see I've got a quadratic equation. It's quadratic because it's got a power of 2. We've got coefficients, and coefficients means the number in front of our term with x or x squared. We've got coefficients of b, we've got a coefficient of a. Now what we want to do when we solve a quadratic equation is find solutions for x. Some people get a little bit confused. A, b and c are just given constants. So I'll write that here, where a, b and c are given constants. And a constant just means a integer or a fraction or a number that doesn't change depending on a variable. So depending on x, you know, it's 1, it's 2, it's 3, or it's a fraction, or it's a surd or whatever. A, b and c are given in the question. We're not trying to find a, b and c. Some questions you might be able to find a, b and c. You might be asked to depending on the question. But when you're asked to solve a quadratic equation, you are trying to find the values of x that make this situation true. Okay, so there are a few types of solutions to quadratic equations. They can either have 1, 2, or no solutions. So I'm going to write that in here. The quadratic equation can either have one solution, and I'll write that just up here. Types of solutions. So one solution, or we can have two solutions, or we can have no solutions. And no solutions is quite important. Now, what I just want to bring to your attention is that this is a quadratic equation. And every equation has the same number of roots as the highest power. So it kind of contradicts here that I've said we have one root, because the highest power in this quadratic is, and I'll highlight it in green, the squared term, because that's what makes it a quadratic. So every quadratic actually has two roots. But in the case where we have one root, what we have, and I'm going to write this underneath here, it's one repeated root. So we get that root twice. And I've just introduced a new word there. Root is the same as solution. I'll write that in, let's go with green. Root is the same as solution. So if you're asked to find the roots, it means find the solution, okay? And it's the solution when it equals to 0. So when we've got one solution, what we've actually got is a repeated solution. We've got that same solution twice. Okay, there's two ways in this video that I'm going to go about solving a quadratic equation. The first one is by factorizing. Okay, so if we've got the form ax squared plus bx plus c is equal to 0, what we want to do is we want to factorize the quadratic. And factorising we've covered in another video. What you want to do to factorise is to get two brackets. One bracket times another bracket will give you that quadratic form. That's the factorised version of that quadratic form. So we're going to factorise the quadratic. Before we factorise though, just note we want to make sure it is equal to 0. So we've got this quadratic, and I'm going to highlight that in green, got to be equal to 0 on the right hand side. Okay, so we want to factorise, and then what we want to do is we will end up with two brackets. That's kind of like part 1. Part 2, we want to set each bracket equal to 0, because that's what the right hand side is, and solve each bracket. Okay, so we'll have an x term in each bracket. We're going to set each bracket equal to 0 and then just solve each bracket. And then we'll get our two solutions, or we might get one solution, and our one solution might be repeated, and also we'll have no solutions in some cases. Okay, so let's have a look at some examples. Okay, here are 4 examples. You can press pause and have a go, and when you're ready you can press play and we'll work through the answer. Hopefully you've pressed pause. Let's have a go. So what we need to do is we need to solve these, and it doesn't really tell us how to solve, but because I've just gone through factorising, it's probably best to factorise these quadratics. In a minute, we'll have a look at what happens when we can't factorise the quadratics, because not every quadratic is factorisable. Okay, so let's have a look at A. We'll zoom in here. I need to solve this quadratic, and I'm going to do it by factorising. I'm going to do the factorising quite quickly because I have had a video on factorising. Look on my channel for some other videos. So the way I factorise is I say, right, I need 2 numbers that times to give me minus 15 and the coefficient of x squared, which is actually 1. So I need 2 numbers that times to give me minus 15 and add to give me, and I'll write that in green, that's where that comes from, and in red, times to give me the coefficient of x. Remember, coefficient is just the number in front of x, so the coefficient of x is minus 2. So times to give me, add to give me minus 2. So now I'm going to list the factors of minus 15, so 1 and minus 15, but they don't add to give me 2, so I'm not going to use those. Then 2 doesn't go into 15, 3 does. We'll have 3 minus 5. They times to give me minus 15, and they add to give me minus 2. So I'm going to use those numbers there. So I'm going to introduce my brackets. So I'm going to have x, and then I'm going to have another bracket and x, and that's going to be equal to 0. It's going to be equal to 0 because I'm just going to take it straight from there. And what I'm actually going to do is just use a little arrow here, because this arrow means implies. It just says this line kind of implies this line. I just don't like putting 2 equals on the same line, so that's what I'm going to do there. So it's basically this quadratic implies that we can factorise it like that. Okay, you don't have to have the arrow if you don't want it. Okay, so what I'm going to do is I'm going to put those numbers in, x plus 3, x minus 5, and we could check if we were to expand these brackets, would we get back to this quadratic where we'd have x squared minus 5 plus 3 would give me the minus 2x, and then minus 15 is what we'd get as our constant. So that works. So we've factorised our quadratic. Now let's have a look at the second thing that we need to do. We need to set each bracket equal to 0, and then we just need to solve each bracket. So here you can see this is the first bracket, and this is, and we'll add little bars like that, that is the second bracket. And the reason we set each bracket to 0, we don't just do it for fun. What we do is we set them equal to 0 because to make this product, remember we're multiplying 2 brackets together, to make this product equal to 0, either this bracket must be 0 or this bracket must be 0. And to make either bracket equal to 0, we need to solve for x. So bracket number 1, if we set that one equal to 0, we will get x plus 3 is equal to 0. We just take what's inside the bracket here and set it equal to 0. And then we can say, well, x plus 3 equals 0. We're just solving a basic equation there. We can just say x is equal to minus 3. I'm just going to highlight that there because look, we've found a solution for x. We've found a solution and we've found a root, because root and solution are just the same thing. It's just a different word. Okay, so we've set one bracket equal to 0, and then let's have a look if we set the second bracket equal to 0. When we do that, we would have x minus 5 is equal to 0, because we're just going to take what's inside the bracket here and set it equal to 0. When we do that, we can just add 5 to both sides, again just solving a basic equation, and we get that x is equal to 5. That is another solution to our quadratic equation. We've found a value for x, and we found another value for x. Now, are those correct solutions? Well, we can substitute them into our quadratic equation and work out whether we get 0. They both are correct solutions, so what I'm going to do is I am just going to, we'll test this first one. So let's say we do the test on x equals minus 3. X equals minus 3, substitute that into the quadratic. X squared minus 2x minus 15 will give us, well, minus 3 squared minus 2 times minus 3 minus 15. That will give me here, we're going to have 9. Minus 3 squared is just the same as 3 squared, which is 9. And then we will have minus 2 times minus 3 will give me plus 6. And then minus the 15, that's the same as minus 15 minus 15, which is 0. And you can see here, that's exactly what we wanted our quadratic to equal. And if we test it with 5 as well, it will work the exact same. So we know that we have worked out the correct solutions. And so x equals minus 3 and x equals 5 is the solution, or the solutions, to our quadratic equation. Okay, let's have a look at B. So here, what we needed to do is, well, first of all, I brought to your attention up here that we need, before we factorise, for our quadratic to be equal to 0. We need the right-hand side to be 0. Now, at the minute, what we've got is 2 plus 3x. So what we need to do is get rid of that on this side. So, to do that, what I'm going to do is I'm going to subtract 2 plus 3x from both sides, and I'm going to do it all in one. So what I'm going to get is, well, x squared, and I'm going to write that as a little arrow, make that a little bit neater. So I'm going to get x squared, and then I'm going to have minus 5x minus another 3x. That's going to give me minus 8x. And then what I'm going to do is I'm going to have 18 minus 2. The reason we're minus in here is because we're adding them on this side, so to get rid of them, we're going to take them away. So we'll have 18 minus 2, which will give me plus 16. And that then is going to be equal to 0, because those have cancelled to give 0. Okay, so now what we need to do is we need to factorise, because we've got 0 on this side here, so let's do some factorising. I need two numbers that multiply to give me 16 and the coefficient of x squared, which is just 1. So we need two numbers that multiply to give me 1 times 16, which is just 16, and they need to, and I'll just highlight that there, they need to add to give me minus 8 from that bit there. Okay, so, well, let's list the factors of 16. 1, and I'll do this in blue, 1 and 16, that doesn't work because they multiply but they don't add to give me minus 8. And then we'll go on to 2, so 2 and, well, 16 divided by 2 is 8. That's not going to give me minus 8 when we add them, so that's not going to work either. Okay, that's not going to work, so let's put a cross. Let's think about, well, 3 does not go into 16. Let's think about 4. It's 4 times 4. Now, I'm going to stop there because when I add 4 and 4 together, I get positive 8. If you've done lots of factorising, you're going to know what I'm going to need to do. I don't want them to add to positive 8. I want them to add to negative 8. So what I need to do is I need to have them both as negatives. And now that satisfies both of these two sort of criteria here. They multiply to give me positive 16 because minus times a minus is a plus. And when we add them, we do get minus 8. So what I'm going to do is introduce my brackets, and I'm going to get x minus 4 from that term there, and then x minus 4 from that term there. And those are going to be equal to 0. Okay, so now what I need to do is I need to solve both brackets equal to 0. So we're going to have x minus 4 is equal to 0, or the second bracket equal to 0. Well, it's the same. x minus 4 is equal to 0. The reason for that is because what we've got is x minus 4 squared. We could write it like that because it would just multiply an x minus 4 times x minus 4. So I'm actually going to do that. I'm going to not solve them both like that because all we're doing is just solving the same equation. I'm going to write it like that. And then all I need to do is just solve that equation. Well, I can square root both sides. Square root of 0 is just 0. The square root of this square here is going to get rid of it. So we will get x minus 4 is equal to 0. And then if we add 4 to both sides, we will get x is equal to 4. And I'm going to write in bracket that it is a repeated root. And the reason that it's repeated, remember, up here, I said we can have one root, but it's kind of one repeated root. Here we've got one root, but we actually get the answer 4 2 times, because remember, I wrote that equation out twice, but then I thought, well, let's do the square. Okay, so yes, our answer is x equals to 4, but we've got x equals to 4 twice because of these two brackets. Okay. So that is our final answer, and it's useful to say that it's a repeated root so you understand what's going on, because it's a quadratic and so it's going to have 2 solutions. Okay, let's make this a little bit quicker here. We want to factorise, and oops, that actually should be an equals sign, so there we go. X squared equals 9x. How on earth are we going to solve that one? Well, the first thing we need to do is get 0 on the right hand side. So I'm going to minus, and I'll do this in green, I'm going to minus 9x from both sides. The reason we minus is because it's a plus here, so they will nicely cancel out to give 0, just like in the question here. Okay, so what I'm going to get with is I'm going to have x squared minus 9x is equal to 0, and I'm just going to write that as a little arrow. Okay, so what can I do with this? Well, I can go through the factorising as normal, and we've just got no constant. So I could say, well, 2 numbers that times to give me 0, and then that's not really going to work. What I can do is I can just take out a factor of x from both terms on the left-hand side. Because it's kind of an example of a common factor factorising here. They've both got a common factor of x, so I can just subtract x from both, factorise x out from both sides. So when I do that, I will have x, and then what times by x to give me x squared? Well, that's just going to be x. So x times x, and then minus 9. And that is then going to be equal to 0. The reason I've done that is because now what I can actually do in grey here is I'll introduce another bracket there. And then all we've got is 2 brackets. It was just an easier way of factorising that because we noticed they both had an x in both terms. So we've factorised now, so all I need to do is I now need to think, right, well, either this bracket will be equal to 0 or this bracket will be equal to 0. So we'll call that number 1 and we'll call that number 2. And then what I need to do is say, right, well, if we set 1 equal to 0, I will just have x equals to 0, and then that's my solution straight away. Or if I set 2 equal to 0, I'll have what's inside the second bracket, which is x minus 9. I'll have that equal to 0. And then if we add 9 to both sides, I'll get that x is equal to 9. And again, we can substitute that into this equation. X squared is equal to 9x is the same as this equation here being equal to 0. If I substitute 0 in, I'll have 0 minus 0, which is 0. Or if I substitute 9 in, I will have 9 squared, which is 81, minus 9 times 9, that's 81 minus 81, which does give me 0. So those are our 2 solutions. Not repeated roots here because 0 is different to 9, so we've got 2 solutions. Okay, let's have a look at D. Here, it's a little bit different. We need to factorise, but we've got a 6 out of the front. So what I need to do is I need to find two numbers that times to give me 6 times minus 5. So we'll do this in blue. Two numbers times to give me minus 30, because 6 times 5 is 30, and then we've got that negative on the 5. So two numbers that times to give me minus 30, and then add to give me the middle number here, add to give me 13. So I'm going to list the factors of minus 30. Let's start with 1. 1 and minus 30. That does not work, so we'll put a cross there. Then let's have a look at 2 and, well, 2 times what gives me minus 30? That's minus 15. Now, if we think about that, that does add to give me minus 13. So what we need to think is, well, I don't want it to be minus 13, I want it to be positive 13. So what I can do is I can say, well, that's not going to work, and we'll do that in red. But what does work is minus 2 times 15. That still times to give me minus 30, and it also adds to give me 13. So that is going to work. So I'm going to put a nice tick next to those. Okay, so what I'm going to do now is I'm going to write that in my bracket. But what I'm going to do is I'm going to carry this 6 in both brackets. And when I mean carry, I mean write it as 6x and 6x. And that will be equal to 0. And then I'm going to put my numbers in, so we'll have minus 2 and plus 15. Okay, then what I do here is I say what number, or what's the biggest number I can divide this bracket by, and what's the biggest number I can divide this bracket by. In other words, 6x and minus 2, the biggest number I can divide both of those terms by is 2. So I'm going to do that. Will give me 3x minus 1, and then I can't divide each term by the same thing in that bracket. And in here, I can divide both of these two terms by 3, and that's the biggest number I can divide by. So I'll have 3x, and sorry, I divided both of those by 2, so that gives me a 3, and that should then give me a 2. Sorry, we divided this bracket here by 3, and then we're going to have 2x plus 15. That will be equal to 0, and I'm just going to check that's correct. That's exactly what we need, apart from that 1 should not be there. Plus 5. So I'll just do it in a orange here. We divided this bracket by 3, and we divided that bracket by, that one was 2, sorry, and that one was 3. That's right. Okay, so the reason we do that then is so that when we expand these brackets here, we get back to the quadratic that we needed to get to. So then all I need to do is think, right, well, do we actually get that? Yes, we get 6x squared. Just do a quick little mental check. We get 15, and then minus 2 gives us a 13x, and then minus the 5. So all we need to do now is set each bracket equal to 0. So we will then have 3x minus 1 is equal to 0, or we'll have the second bracket equal to 0. And when we have that, we will have 3x is equal to 1. So x is equal to a third, or we will have 2x is equal to minus 5, so x is equal to minus 5 over 2. And those are our two solutions, or two roots, to this equation here. And again, substitute your answers in and see whether you get 0 on the right-hand side. If you don't, then you've probably made a mistake somewhere. Checking those are correct, those are exactly what we need. So those are just some examples of solving quadratics by factorising. In the second half of this video, what we're going to have a look at is using the quadratic formula. So let's ask a question. What happens when the quadratic does not factorise? What we do here is, well, we can actually do a few things. In this video, we are going to solve using the quadratic formula. I'm going to write this in green. Solve using the quadratic formula. Now you should know the quadratic formula from GCSE, so I'll state it to you now. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. That is, and I'll highlight it in red, that is our quadratic formula. It might be better if I just change the colour of that and not duplicate. There we go. That is our quadratic formula. A, B and C in this formula just correspond to our A, B and C in our quadratic formula there. So all of these correspond to the A, B and C in there. So it's just kind of a game of substitution. So let's have a go at an example, and I'm only going to do one example here because really all it is just substituting, and you probably have done this at GCSE. Okay, so one example, let's have a go, and in fact I don't even need to write A. What I want you to do is I want you to solve using the formula. And the quadratic I want you to solve is 3x squared minus 7x minus 1 is equal to 0. So you can pause and have a go if you want to, or we can work through it together. If you paused, let's work through it together and let's see whether you got the right answer. So the first thing I'm going to do is I'm going to compare this to the form that the quadratic equation actually solves. It's this form here. Now, this quadratic does not factorise. That's why we need to use it or solve it using the formula. And the reason I know it doesn't factorise is because if I tried to factorise it, we would be getting two numbers that times to give me minus 3 and add to give me minus 7. The minus 3 came from multiplying those two numbers there. And then the minus 7 came from just the middle term of the quadratic. Now, let's try and think. Well, 1 and minus 3, they multiply, but they do not add, so it's a big cross there. And then, well, okay, 3 and minus 1, that doesn't work, and then we're stuck. We can't find any other factors of 3, and that's because 3 is prime. So that's not going to factorise. Let's get rid of that there. So we need to use the formula. In this example, we have that, well, let me just get rid of those there. We have that A is equal to 3, B is equal to minus 7, and C is equal to minus 1 in this example, okay? And if I do some highlighting, there's A being equal to 3, there's B being equal to minus 7, and there's C being equal to minus 1. So what I'm going to do is I'm just going to state the formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over, put that as a straight line, all over 2a. And then I'm just going to substitute in. So what I'm going to get is x equals negative b, so that's going to give me plus 7, because what we really have is that, minus b, which is minus 7, so we'll write that straight away as 7, plus or minus. The reason we've got plus or minus is because we're going to have two roots. They might be the same, we don't know. So, plus or minus the square root of b squared, which is minus 7 squared, minus 4 times a, which is 3, times c, which is minus 1, all divided by 2 times a, which is 3. Okay, so that then tells us that x is equal to 7 plus or minus the square root of minus 7 squared. We're doing the minus 7 squared under the square root here, which will give me 49. And then minus and a minus is going to give me a plus. and then I'm going to get 4 times 3 times 1 because we've done the sign there. So it's just 4 times 3, which is 12. Then on the bottom here, what I'm going to have is I'm going to have 6. And just checking, that's exactly what we need. Okay, that's the end of the square root there. So now I can simplify what's under the square root. So I can have x is equal to 7 plus or minus, it's just going to be the square root of 49 plus 12, which is 61. So we just get the square root of 61 there. And then divide that by 6, okay? And we can't do any more simplification. That's all we can do. The reason we get this answer is because this quadratic does not factorize. We could have actually solved all of these quadratics by the quadratic formula, but we would just get our nice answers out the front. So all I can do here is just say, and I'll say, and so x is either equal to 7 plus root 61 over 6 or 7 minus root 61 over 6, because we've got a plus or minus here, so it's either a plus or it's a minus. So that is how we solve using the quadratic formula, and if you want to have a go at another example, here is a question you can discuss in the comments.